Welcome to online lecture series of Engineering Mathematics 2. Today we will just continue with reduction formulae, and today we will cover reduction formulas for tan x, cos x and sec x. If the index of your tan cot sec is greater than 2, in general, if the index of your tan cot sec is n, and n is the integer which is greater than 2, then how to derive the reduction formulae for these three trigonometric functions? So we will start first reduction formula for your tan x, and the example in the form of find reduction formula for integration tan raised to n x dx. In this integration, the limit is not given. So we have to assume this integration is equal to some letter. Here the index of your tan is n, so we have to assume the given integration is equal to in. So we say that in is equal to integration of your tan raised to n of x dx. Then the second most important step to derive the reduction formula, to split the index of your tan whose in the form of functions such that one function's integration can be calculated very easily and second function's derivative is calculated with the help of partial derivative terms. So we have to split the index of your this tan. The index of your tan is splitted in a such a way that the n is splitted into n minus 2 plus 2. So the integration in which the product of two tan function is tan whose index is n minus 2 of x, then tan square x dx. But we don't know the integration of your tan square. We have to convert the tan square into sec square. So the formula for the tan square is sec square x minus 1. So replacing the value of your tan square, that is a sec square x minus 1, here conversion of your tan square, and we say that this is we have change bracket. So after making the multiplication, the integration becomes integration tan raised to n minus 2 of x into sec square x minus tan raised to n minus 2 of x. So we get this step after the multiplication of the bracket with tan raised to n minus 2 of x. We have to make the separate integration of these two terms. The first integration becomes tan raised to n minus 2 of x sec square x dx. In between the minus integration tan raised to n of dx. Then we have to just the integration. If we put tan x equal to some variable u, the derivative of your x is square x dx, and the derivative u becomes so we change the variable x by assumption equal to u. So tan is so we get index because index of your is n to n is to n minus 2 and the this. Then taking the integration of your u raised to n minus 2, just using the formula of your x raised to n, and that formula is x raised to n upon x raised to n plus 1 upon n plus 1. Here we have to add the index of your u, or we have to increase the index of your u by 1. So the index of your u becomes n minus 1 divided by your n minus 1 is the integration of u raised to n minus 2. And this right hand side, the second terms, tan raised to n x dx is in. The index of your tan is n, so we are denoted this in here. In this integration, the integration of your tan is n minus 2, so we have to assume this particular term is I of n minus 2. And lastly, we have of your u. U is nothing but your tan x, so the in becomes in is equal to tan raised to n minus 1 of x divided by n minus 1 minus I of minus, which is the formula. This is the reduction formula for the tan. So in the similar way, we can find the reduction formula for your cot raised to n of x. The same conversion we have to just perform to find the reduction formula for your cot. The first step, we have to just write the value of this integration is equal to some letter. The index of your cot is n here. So the integration is denoted by in. Again, we have to split the index of your cot. Again, in a similar manner, we have to split the index of your cot is n minus 2 and cot square. Again, we know that the value of your cot square is nothing but cosec square minus 1. We have to change the value of this cot square is equal to cosec square minus dx. Then we have to make the multiplication with this. Means cot raised to n minus 2 x is multiplied to your cosec square x minus 1 terms. So we get 2 integration, that is cot raised to n minus 2 x into cosec square x. Is the first term after making the multiplication, and the second term, that is a cot raised to n minus 2 of x dx. So again, we have to just find the integration to put the cot. Cot x is equal to u, and we know that the derivative of cot x is cosec square x dx du. So we have to change it. The cot index is n minus 2, so it becomes minus u raised to n minus 2 du, because the value of your cosec square x dx is minus du. And again, the value of integration cot raised to n minus 2x dx is nothing but I of n minus 2. So we have to just replace the value of your u. U is nothing but my cot. Before that, we have to take the integration. Integrating this u raised to n minus 2, we get in is equal to minus times u raised to n minus 1 upon n minus 1 minus I of n minus 2. And lastly, replace the value for u is equal to cot. We get a simplified form, or we get the reduction formula for your cot raised to n. We are multiplying this minus sign to your n minus 1. So the sign of your n and get changed. So we get reduction formula for the cot raised to n is cot raised to n minus 1 of x divided by 1 minus n of n minus 2, which is the reduction formula for cot. Lastly, we can derive the reduction formula for sec. And with the help of reduction formula, we have to find the value of the integration who runs from 0 to pi by 4 is 6. And we have to find the value of this integration. Before that, we should know what is the reduction formula of your sec. In a similar manner, we have to assume the given integration is equal to in, because the index of your sec is n. So we assume in is equal to sec integration of your sec raised to n of x dx. Then we have to split the index of your sec. Again, we are splitting the index of sec in two terms. In becomes sec raised to n minus 2 of x sec square x dx. And we have to use the by parts formula. When we compare with the by parts formula, the value for u is equal to sec raised to n minus 2 x, and v is equal to sec square x. So putting the value for u and v, we get the value for in. So in is equal to sec raised to n minus 2 of x integration of your sec square x dx minus integration derivative of your u function into integration of your v function, that is tan x and whole functions integration. So after taking the integration of your sec square, it becomes tan x. Integration of your sec square x is your tan x. And we have to find the derivative of your sec raised to n minus 2. So n minus 2 with the help of your x raised to n formula, n minus 2. Index of your sec reduced by 1. That is, it becomes n minus 3. And again, the derivative of your sec is sec x tan x. And lastly, here the integration of your sec is tan x. Then sec raised to n minus 3, and this sec, we have to just add the index of your sec, and tan x becomes tan square. So we are making the index conversion. So in becomes sec raised to n minus 2 into tan x minus n minus 2 is a constant outside integration. Index of your sec becomes n minus 2 and tan square x. Again, we know that the value for tan square is nothing but sec square x minus 1. We are replacing the value for tan square x is sec square x minus 1 dx. And multiplying this sec raised to n minus 2 into the bracket, we get this sec raised to n minus 2 of x into sec square x becomes sec raised to n minus 1, and in this a minus sign is present, so I forget here, minus sec raised to n minus 2 x dx. This is the integration in which two particular terms are present, so we have to make the separation. So we are making separation. So in becomes this. So this minus sign of n minus 2 multiplied to your sec raised to n. Again, this minus sign n minus 2 multiplied to this minus times sec raised to n minus 2. It becomes positive. When we observe this is nothing but my in. And when we observe this is nothing but my I of n minus 2 is get multiplied to your n minus 2. I of n minus 2. We have to shift this in to your left hand side. It becomes plus times n minus 2 of in. And after making the simplification of this, here these terms to right hand side. Minus 2 of IN. And we have to make the calculation. Its coefficient is 1. Its coefficient is minus 2. The minus 2 and plus 1 is minus 1. And taking IN common. We require IN. So we have to divide this entire step by so for its sake to us to find the value of this is the reduction formula for sec. We have to find the value of your sec whose index is 6. This is the reduction formula of your sec raised to nx dx. And now we have to find this. For this, we have to use this IN reduction formula for your sec, replacing the value for upper and lower limit. So here we are putting the upper and lower limit here. This is the conversion. We have to put the upper and lower limit here because we already integrated particular terms. Replacing the value, we get IN is equal to sec raised to n minus 2 of pi by 4. This is the replacement of your upper limit minus times replacement of your lower limit, and the last term remains as it is, that is a n minus 2 upon n minus 1 of I n minus. Replacing the value of this sec pi by 4, know the value of 4 is both are similar. Sec to n of pi by 4 is equal to sec to pi bracket. So we are replacing the value sec pi by 4 and 0 is equal to 0. So 0 into something becomes 0. The lower limit, when we put it, the answer is 0. So the value of your IN is equal to this root 2 whose index is n minus 2 upon n minus 1 plus n minus 2 upon n minus 1 I of n minus 2. So with the help of this reduction formula of your sec whose limit runs from 0 to pi by 4, we have to find the value of your n is equal to 6. For this, we have to replace the value of your n equal to 6 in your equation number A. So when we replace the value of n equal to 6, it becomes I6 is equal to root 2 as it is, 6 minus 2 becomes 4 and n 6 minus 1 becomes 5. N minus 2 means 6 minus 2 becomes 4 and 6 minus 1 becomes 5. And again, we don't know the value. When we're replacing the value of your n is equal to 2, we get I2. I2 is equal to root 2 raised to 0 upon 1 plus 0 upon 1 I0. When we simplify this, 2 raised to 0 becomes 1. 1 upon 1 is 1. Again, 0 upon 1 is again 0. 0 into I0, 0. The final solution of this I2 is 1. So we have to replace the value for I2 in I4 and value for I4 in I6. So we can find the value for I6. So replacing the value for I2 is equal to, so equation number 1 becomes, see here, this is the I6. The I6, this is the value of your I4. Highlighted in a green color. This is the value of your I4. But in I4, the value for I2 is unknown. So we have to replace the value for I2. So replacing the value for I2 in this, the value for I2 is equal to 1. Root 2 raised to 4 is 4. 5 remains as it is. Again 4 upon 5 remains again as it is. Root 2 square is 2 divided by 3. It becomes 2 upon 3. 2 upon 3 into I2. The value for I2 is equal to 1. So after simplifying, we get a value for I6. And it is 4 upon 5 plus 4 upon 5 multiplied by 4 upon 3. So we get 4 upon 5, the first term as it is, plus 16 upon 15. 4 4s are 16, 5 3s are 15. And lastly, we get a solution of this 28 upon 15 is the final answer of your I6. What does it mean by I6 then? I6 equal to this. Integration of your sec raised to 6x dx, where the limit runs from 0 to pi by. This is the value of your I6. So with the help of this, we can find the reduction formula for the remaining trigonometric function when this limits get changes. So in this way, we can make the reduction formula for the trigonometric function. We will stop here. We will see on the next lecture. Thank you.